We started the topic of traffic data collection. We looked at some of the sources, okay, some of the studies, okay, we covered a lot of them, and some of them were asked today as well in the quiz. We have three methods of data collection: manual, semi-automated, automated. Manual studies are limited because people do not, or the accuracy level is lower. So if we continue it for longer times, the error increases, okay, multiplies or something. Okay, so manual studies are short and they can be done for specific purposes, which are mentioned here. Okay, we were talking about manual counting. Within manual counting, we talked on the concept of breaks. The breaks can be within the counting period, so a longer counting period, a shorter break period, and there's a total period as well. It can be alternate, so counting and breaks are of the same value basically. Okay, so 15 minutes of counting, 15 minutes of break, something like this. And when we moved on to this example where we have uh, two people who are counting 4 lanes. So I told you if you do it lane by lane, the chances of errors are less because vehicles will pass one by one. But the problem is we have less observers. So what they did, they made a plan, 12 minutes counting for one lane, 3 minutes of break, and then 12 minutes of counting for the other lane. So what I asked for last time was that you convert all these 12 minutes count to 15-minute counts. So these values multiply by, divide by 12, multiply by 15, and then you fill in the missing values using the method of average. Okay, and I told you how to fill in the first and the last value as well. So can somebody give me the values? Okay, the filled, the complete table. Somebody did that. You can simply share it on Teams. Somebody did the full table, the 15-minute counts and the filling in the missing values. Does somebody have it? You can show it. You can, I believe you can like just copy and paste it as a column, as a table. It works this way. That is if you have it, obviously. Yes, anyone has this? Ban, if you have it, yes, you can. Okay, so it's like this, huh? Okay. Okay, how can we use it? Let's see. Hmm. Okay, values seem correct. Does somebody else did it and they have like a version where I can just take the values and do the next calculation, because then I have to like write all these values. So anybody has like a digital form of this complete table? Somebody else did it and they have like something I can just copy into an Excel file or Word file and start using it. But this will take like time. You can still use it, copy it. Let's see. Okay, so these are the values you are talking about, the small ones. What is this? Speed data? Why? We don't need speed data. What is this? Okay. The full question you mean? Okay. Thanks for that. Okay. What I can do is okay. For the others, I will recommend them to do it. But what I will do is I will explain the procedure for the remaining items. Okay, and then you can like do it on your own whenever you have time. Okay. Just checking if somebody else. Okay, no one else. Okay, so thank you, Bayan, for doing this. It's a great help. It helps me to move faster. Okay. So okay, so I'm always happy to like skip around something like this. Okay. So after doing the calculations I explained last time, you have um, values for every 15 minutes. So each of these values is for 15 minutes. So 340 is for from 4 to 4:15. 360 is from 4 to 4:15. Similarly, no, sorry, 425. Sorry, this 425 is from 4 to 4:15, and this 437.8 is also from 4:15 to 4:30. Okay, so the values which you see here are all for 15 minutes. Okay, so she converted all the values using this divided by 12 multiplied by 14 to 15 minutes. Okay, and then some of them the missing values. Okay, so before doing this conversion, she did the missing value. So between 330 and 310, she found the missing value. Okay, and once you have these two values, you can find this one because 310 should be a average of 295 and 325. Okay, so if you are missing the extreme value, then you look for the previous two values and apply the formula of average. Okay, so once what happened? Okay, so pay attention now. Okay, it's very important. Once you have these values, okay, these values in the small columns. Okay, the next part of the question was find out peak hour volume, and peak hour factor for each direction and for the whole for combination of both directions. Okay, so freeway is the combination of both directions. Okay, what they're calling is freeway is a combination of both directions. Okay, so what is done here? Each of these values in the small columns you see is for each lane. Each direction has two lanes. So when you combine two lanes, you get the full. When you combine two lanes, you get the full of that direction. So 425 from here, 450 from here, you get the total of this direction in this time, 4 to 415. Okay, then 437.5 and 462.5, you combine them, you get 900, which is the total of this direction for the next time interval. Okay, and the same thing for westbound as well. Okay, so 347 plus 387, you get this one. Okay, so this is the combined. So you take each lane's full 15-minute count and you combine it with the next lane and you get the direction. Okay, and this next column is when you combine both the directions. So this direction total was 875. This direction total is 734.5. You combine them, you get this one. Okay, normally when you are talking about counting, we round it off. Okay, so you don't have to write the decimals at all. So counting means you have full vehicle. Okay, normally counting you will see in my notes and the book, counting does not have decimals. Okay, so this is the only change, but the procedure is correct. Well done, Bayan. Okay, so next time interval 900% 56, you get the total. Okay, now each of these values which you see in blue color here. Okay, so you have done the color coding as well. That's very good. Okay, so each one of the blue values is for 15-minute count. Each one of the blue values for 15-minute count. Okay, now for 1 hour, 1 hour means 4 values of 15 minutes. 1 hour means 4 values of 15 minutes. Okay, so I have these 4 values. So this one is starting at 4. Okay, starting at 4, and the next 4 values 1, 2, 3, 4. So it is ending at 5. Okay, when you convert it to full 15 minutes, it will be 5 o'clock, right? Not 4:57. 4:57 has 3 minutes of break. So when you remove the 3 minutes of break, fill the 3 minutes break, it becomes 5. So 4 to 5. Okay, these are the 4 values. So this one, this one, this one, this one. So this is the value you got. Okay, this one 3063. Okay, so how did we get 3063? 875, 900. I believe it's the other way around. Yeah, this is eastbound. Okay, this one is the eastbound. Okay, so how did we get 3632, 875 plus 900 plus 925 plus 931.5? Okay, so this gives us 3632. Okay, next hour. Next hour means next 4 values. Okay, next 4 combination of values. Okay, so the first combination I made from the starting from 4. Next combination can be made starting from 4:15. So 4:15 to 5:15. That will be the next combination. Okay, so we are not looking for the clock hour. We are looking for 60 minutes hour, any combination of 60 minutes hour. Okay, so the first combination started from 4. The next combination started from 4:15. Okay, so now I will add 900 plus 925 plus 931 plus 909. This is how you got 3666. Okay, so you pick all combinations of 4 values, okay, which are in sequence. So the first 4 values, then starting from the next one 4 values, starting from the next one 4 values, starting from the next one 4 values. Okay, so the first 4 values are 4 to 5. Okay, the next one is 4:15 to 5:15, then 4:30 to 5:30, then 4:45 to 5:45, then 5 to 6. Okay, so this is why we have 5 values here. The first value combination of 4 to 5, then 4:15 to 5:15, 4:30 to 5:30, 4:45 to 5:45, 5:45, 5 to 6. Okay, so in each of these columns for each direction separately, there's for eastbound, you need to correct this beyond, and this is for westbound, and this is from this column, the total of the 2 directions. Okay, the same thing is repeated. You combine first 4 values, the next 4 values, the next 4 values, and so on and so forth. Okay, now before I move on, does anybody have any questions? It's tricky. Okay, so anybody has any questions? I just like give you 10 seconds to think about it. So do you have any questions about any of these? The next step is very easy, by the way. She did all the hard work. You should like thank her and, you know, pray for her and whatever. Yes, anybody has any questions? Okay, so I believe that is clear. I will go to the last item basically. No, not the last item, sorry. In this one, we still have to calculate the peak hour factor. Okay. Now in each column, you see 5 values of volume. Peak hour factor is calculated for peak hour. You cannot do it for any hour. It has to be the peak hour. Peak hour means the hour which has maximum volume. The hour which has maximum volume. Okay. So peak hour means the hour which has maximum volume. So which value is maximum here? Okay. If you look at these values, we have 3666. Okay, the maximum value in this column is 3666. And you remember it's the second value. Okay. So which combination of time is this? What is the timing of this value? Starting from where going up to where? Can anyone tell me? Okay, I made these 5 values using combination of 4 values each, right? So the second value means starting from where to where? Anyone? The second value is a combination of which 4 values? No. I'm talking about this one, 3666. So which combination is that? Four 15 to 515. Yes. Yes. Okay, you are correct. So this is 415 to 515. Okay. Second combination, starting from the second value. So 3666 came from these 4 values: 900, 925, 931, 909. Okay, these 4 values. I'm looking at these 4 values. So peak hour factor, okay, is the ratio of, write it here. Peak hour factor is the ratio of volume. Volume is this 3666. Okay, divide by 4 multiplied by peak 15 minutes flow. Okay, and this is why I asked which interval we are talking about. Okay, because then you cannot know the peak 15 minutes. Okay, so I have to look into the 15 minutes values for this hour, 415 to 515. So from the second value onwards. Okay, so in this combination, you can see the highest value is 931.5. Okay, 931.5. So this has to be corrected then. Okay, this has to be corrected. So now we can do it ourselves. Okay, Beyond doesn't have to do everything. So the combination came from here, from the second set. In this set, the highest 15 minutes is 931.5. Okay, so the peak hour factor will be 3666 divided by 4 into 931.5. So how much is this? Yes, 0.98. Okay, good. So 0.98. Now for the second one, again, now we have the problem here because there are 2 values which are of the same number and they are the highest values. Okay, one is this one from the second combination, the other one is this one from the third combination. Okay, so when you have this dilemma, okay, you look, if I take this combination, will I get the highest 15 minutes? Or if I get this combination, then that will give me the highest 15 minutes. Okay, so if I take this combination, the highest 15 minutes is 794. Okay, and if I take the next combination, the highest 15 minutes is still 794. Okay, so in terms of peak hour factor, it will not make any difference. Okay, because peak hour factor is what? Volume. Volume is same, 3116, 3116. What other thing can make a difference? Peak 15 minutes. Okay, so if I take the first 3116, my P 15 minutes is 794. If I take the next 15 minutes, next combination, my P 15 is still 794. Okay, you start from 778, 994, 87, 56. So 794 is the top in both cases, so it doesn't matter. Okay, in both cases you are doing the right thing. Okay, peak hour factor will not change. So that's why 3116 divided by 4 into 794, you get 0.98. Okay, whether you take this 3116 or 3116, it doesn't make any difference. Okay, so peak hour factor remains the same, no problem here. Okay, so this could be from 415 to 515 or 430 to 530. Okay, this can be any of the timing, because one of the part in the question is you have to find out which one is the peak hour, the timing of the peak hour. Okay, so in the first case we said is 415 to 515. Okay, this one. In the second case, it could be 4:15 to 5:15, or it could be 4:30 to 5:30. Okay, for for making it similar, we can say 4:15 to 5:15. We can say we took the first combination of values, okay, not the second one. Okay, so we took the first 3116, now the second one. So it will only change the timing. Okay, it will only change the timing. Okay. But 4:15 to 5:15 and 4:30 to 5:30, both of them are peak hours, both of them have the same volume. Okay, now we will look for the combined one. Combined one is not here. Maybe Piano already did it. It's not here, but we will do it for the sake of the class. Again, I will look for the maximum value. So in this case, it's easier. The maximum is 6776. 6776. Second value, again, meaning 4:15 to 5:15. Okay. So peak hour volume 6776. Peak hour 4:15 to 5:15. Okay. Now look for the peak hour factor. So volume is this one. I have to look for the peak 15 minutes. So I took the second combination. Okay. So values are these four. Okay. In these four, the maximum is 725.5. Okay. I'll call it 726. Okay. So peak hour factor for both directions combined will be 6776 divided by 4 multiplied by 1726. I'm rounding off, okay? Rounding off, just simple rounding off, like you know it. Okay. So how much is this peak hour factor? 0.98. Okay. Now, just a word of caution here. In this freeway, maybe it's an urban freeway. So both directions were having the same peak hour factor and same peak hour volume and the same timing of the peak hour. But this is just for the sake of this example. In some other example, these values can change. So do not assume that if I got 0.98 for one direction, then everything should else would also have 0.98. Or if I got 4:15 to 5:15 for one direction, then every other direction will be the same. Okay, it's not a rule. It's not a rule. Okay, especially both directions do not have peak in the same time, because people are either coming more or going more. Okay, it's normally not the same. But in urban areas, city centers, like which are the commercial areas, you will see this pattern. Okay, but obviously it's a special case. It's a specific case. Okay, so it's not a rule that you will get the same value for all directions and all things. Okay, now I can move to the third part of this question. Okay, again, I will explain. I have the answers I can show you. Okay, third part, they are saying we need to calculate the flow rate. So from the flow, I need to calculate the flow rate. Okay, these values in this table, because they did not say it for each lane. Okay, so you can do it. All these values here in the first table in the small column are also flow values. They are also flow values. Okay, so I can convert them into flow rates as well. And these values are also flow values. They're also for 15 minutes. I can convert them into flow rates as well. Okay, but they not say for do it for each lane. Okay, so I will do it for each direction and the combination of the directions. Okay, so I'll do it for this part of the table. Now, if I got flow for 15 minutes, how do we convert it to flow rate? For that, you must know what is the difference between flow and flow rate. So if I convert this to, if I have flow for 15 minutes, how do we convert it to flow rate? Divide by 0.25, yes. Divide by 0.25, multiply by 4, same thing. So yes, you are right. Okay, so I pick all these values one by one, divide by 0.25. Okay, all these values. Any value which is 15 minutes can be divided by 0.25. It will be converted to 1 hour. It will become per hour, and then that is called as flow rate. Okay, so when you pick a value from 15 minutes and you convert it to 1 hour per hour, that is called a flow rate. Okay, so this is what is to be done. So each of these values. So you pick 875, divide by 0.25. You got how much? 35504. Okay. You will see some small differences here from the values of the previous slide. These are rounding off differences. Okay. So Byan got 875, I have 876. No problem. Okay. So if the value is 901 divided by 0.25, you get 3604. Okay, so this is called flow and this is called flow rate. Okay, so there's a problem here. This is not this is not per hour. Okay, so make this correction in your slides. These values are not per hour. These are per 15 minutes. We are converting them to per hour. Okay, so make this correction in your slides. The values are 15 minutes. We're converting it per hour. That is after conversion called flow rate. Any questions? Anybody has any questions? Okay, so I can move on. Moving on to manual speed studies. Manual speed studies. So you can collect speed data using a speed gun. Okay, not a speed gun, a speed radar. Okay, the one which the ministry uses for over speeding is called a speed radar or a speed detector or a speed sensor. Some of these are installed on the roads as well near signals, okay, for yellow timing. But the ones which you see for overspeeding are called speed radars. So we are not talking about those speeds. Obviously, these are not manual, right? The instrument or the sensor is taking your speed data, so that is not manual. Manual speed studies can be done in two ways. Either using distance and a stopwatch. Some of you have done it for your projects, or using a speed gun. Okay, a good example of a speed gun is if you look into your app store, okay, or Apple store, whatever, you will see the app for speed gun. Okay, so you can try it for your project or like just for the sake of trying. So that is a speed gun. Okay, so that gives you like with the distance and stopwatch, you have to measure the distance, do distance upon time, the uh, you will get the speed. Okay, so you take the time, then you do some calculation to get the speed. Okay, but speed gun, you don't do any calculations. Okay, there are no calculations with the speed gun. You face the speed gun or you point the speed gun towards the road. When the car passes, you press the button and you see the speed on the screen. Okay, now the point is, why are we calling it as manual? Okay, so the rule for a manual study is when a person has to be on the site to collect the data. If you put the instrument on the site, sensor on the site, and you go away, and the instrument can still collect the data, that is not manual. Okay, but if you go to the site, you place the instrument, and the cars keep on passing, the instrument does nothing. Then that means that the instrument is for manual studies then. Okay, take the example of a stopwatch. If I put the stopwatch on the side of the road, the car passes, the stopwatch will not do anything. It will not start and stop by itself. You have to do it. Okay. So with a stopwatch, although a stopwatch is a device, but still the study is manual. Okay. Same thing with surveying devices. Okay, you have a theodolite, you have a total station, you bring it to the site, you put it on the stand, and there's some person who is standing on the other side with a rod. The total station will not take the observation until you focus it, until you do something with it. Okay, so yes, there is an instrument, but the study is still manual. So manual studies can involve an instrument, but that instrument does not take observations automatically until you do something with it. Okay, so that's the difference between manual and automatic studies. So if you have a speed gun, you're standing on the road, you press the button, you get the speed. Your problem is solved. You can do it as many times as you want. There is no there's no need to adjust the observations later on. But if you are doing it with a stopwatch, doing it with a stopwatch has two types of errors. One is the random error, the other one is the parallax error. There's a random error and there's a parallax error. Okay, you can see it over here. The parallax and the random. Okay, I'll start with the random error. When the car reaches the starting point of the distance, you press the button. There could be some difference between the car reaching and you pressing the button. Okay, and this difference could be negative or positive, meaning you could have been 0.1 second late or you could have been 0.1 second early, because when the car is moving, you cannot time yourself exactly to press a button when the car is exactly on the line itself, on the dot itself, the starting dot, the starting point. Okay, so you are sometimes a little bit early, sometimes a little bit late. Okay, but you are not doing it on purpose. Okay, you are not planning that this time I will be 0.5 seconds late or this time I will be 0.5 seconds early. You are not planning it. Okay, and it is happening randomly in both directions, plus and minus, early and late. That's why we call it random. Okay, when something is done without any planning, without any trend, without any pattern. Okay, so there is no pattern here. Okay, 0.1 second late, maybe next time 0.2 second late. Maybe you are next time you are exactly on the dot. Okay, so this is not planned. So that's why it's under random errors. And with random errors, when you take observations and you average them, the random errors cancel out normally, or the large portion of random error cancel out, because some of the errors were positive, some of them were negative. Okay, so statisticians say that when something is happening randomly, so it happens in both ways in equal number of times, equal amount of times. Okay, so this is the theory of the statistics when there is a natural random error, a natural random error. Okay, then the magnitude on the negative side is same, almost the same as the magnitude on the positive side. So taking an average or taking a mean should cancel them out. The negative error and the positive error should be cancelled out. So this is according to statisticians. So yes, using a stopwatch has an error which is called as a random error. But to cancel out the random error, you just need multiple observations. That's it. The other one is a parallax error. Now, before I explain the parallax error, I want to ask you, where did you see parallax error before? Where did you hear about parallax error before? Talking about parallax error. In which other course you heard about parallax error? Yeah, anyone? In which other course you heard about parallax error? I can make it easier for you. In which other course you heard about random errors? They were in the same course. So which course was that? Surveying, yes. Okay. So like it should be easy whenever I ask about something. It's normally surveying or highway. When I'm asking about other course, it's normally surveying or highway. So they are very much connected. Okay. So yes. So what is the parallax error? The error which is created by the line of sight. Okay. Error of line of sight is called the parallax error. What does it mean in speed studies? Okay. So normally what people do, there will be an observer on the side of the road. And this is the starting distance, starting point of the distance. This is the end point of the distance. So when the car is at this point, this observer will start the timing. When the car reaches the end point, he should stop. And he will note down the time. He will do distance upon time to get the speed. This is what should happen. But the problem is when you are looking at things from an inclined line of sight. So here your line of sight was straight, but here you are looking at the car at an inclined line of sight. So you can see here, according to this line of sight, the car and the end point of the distance are in alignment when the car is in this position. But you can see car did not reach the end of distance D. The car is before distance D. So when I say the car took X seconds for distance D, actually it did not take X seconds for D. It took X seconds for D effective. So now this will create an error in my speed calculation as well, because I'll be doing distance upon time. So I need to take this distance, the effective distance, which is actually covered by the car, not this one. Okay. So to get this distance, I need the distance between the road and the observer, and the angle between the observer line of sight when he is looking at the endpoint, at the start point and between the endpoint. Okay, the angle created by the line of sight between the start point and the end point. So you need to find out these two values. Let us look at an example. Okay, so let's say we are doing a speed study, and the distance which is set for the speed study is 400 feet. Okay, a terminology here used here, which is called as a trap length. Okay, so trap length is a distance used for speed studies. A trap length is a distance used for speed studies, for manual speed studies. So in this case, it's 400 feet. So whatever timing I get, I will assume that's for 400 feet. But as I've shown you, parallax error dictates that's not actually 400 feet. Okay, so we need two things here. We need to know how far the observer is standing from the road, away from the road. So he is standing 60 feet away from the road. Okay. So this distance, D1 is 60 feet. Distance from the observer from the road, 60 feet. And I also need to know this angle. Okay, so this angle is given as 60 degrees. Okay, again a coincidence. Okay, it's not always the same value, 60 feet and 60 degrees. Just an example. Now this observer in this position notes down a time of 8.3 seconds. Okay, so he looks at the car in this position in 8.3 seconds. From here to here, the car takes 8.3 seconds. Okay, to get the real speed of the car, I must find out D effective. Okay, so how do you find out D effective? For that, you need to look at this triangle. So there's a triangle, observer, starting point, position of the car. There's a triangle. Okay, the observer, the starting point, and the position of the car. This is a triangle. I have this angle. If you see, for this angle, D1 is my base and D effective is my perpendicular. Okay, the angle is with the base, right? So D1 is my base and D effective is the perpendicular. So we know tangent of the angle will be perpendicular upon base. Okay, perpendicular D effective, base 60. Okay, angle was 60 degrees and the distance is 60 feet. Okay, so that means that D effective equals 60, this 60 distance into tangent of 60, the angle. Okay, so how much is my D effective here? $103.9. Okay. Okay, so whatever time I got, you can see the time. The time was recorded 8.3 seconds. To get the speed, I should be recording. I should be calculating the speed using this distance, not the actual trap length of 400 feet. Now you can see there's a lot of difference here. The actual distance D was 400 feet. The effective is not even half. So you can see how much problem it will create when you are calculating the speed using this. Okay, so 103.9 divided by 8.3 seconds, and you get how much? How much the speed? Okay, this is 12.5 feet per second. Okay, if you want to convert it into miles per hour, you will divide this whole thing with 1.47. Okay, so you can see if I increase the value of D1, I will most probably I will increase my D effective as well. Okay, so you can play around with the angle of your line of sight. Angle you cannot play around, but you can play around with the distance. When you change the distance, your angle will also change. Okay, so you can play around with the D1, how far you should stay from the road, how close or how far, and that will change the parallax error. Okay, so any questions here? Anybody has any questions? Okay, just a couple of things you need to keep in mind, and this is important for your term project as well. One of the tasks in your term project, not from the first task, even for the second or for the final submission, you have to do another speed study. So keep these points in your mind when you are doing the speed study, the final one. The first one was a trial, the final one. Okay, first of all, when you see a car is too fast or too slow, you don't measure its speed. Okay, because that's a anomaly. That's a very rare case. So we don't want to include the rare cases in my data because that will disturb the average. Okay, I told you random errors are cancelled out when you take the average. But when you take these special cases, a car, everybody is going at 100. This one is an F1 driver going at 200. Okay, or this one has a problem in his car and he's going at 30 kilometers per hour. Okay, so you can see the fastest car, you can see he will go and you will not even notice. You will just feel that, oh, wind has blown over your face. Okay, and the slowest car, everybody is abusing him and honking him and so on and so forth. Okay, so we avoid these cars because that will disturb the average. Average is disturbed, that means random errors are not cancelled out. If you have a platoon of vehicles, I use this term in lecture 1 as well. Platoon means cars which go together from an intersection. So when you are passing from the intersection, you are in a queue. Okay, so the first car in the queue dictates the speed. The first car in the queue decides the speed. Other cars, until they are part of the queue, they have to follow. Okay, so if you see cars which are going closely one after another from an intersection, until they are so fast that they are no longer one after the other, they are part of the platoon. So in the platoon, you look at the first series of the cars, the first 3, 4 cars, like meaning if you have 3 lanes, the first car in each lane. Okay, so in a platoon, you look at the first car. And heavy vehicles are not considered part of speed studies. Heavy vehicles are not considered part of speed studies, normal speed studies. Okay, there are special cases for which you do that, but normally heavy vehicles are not considered part of speed studies. Okay, so 3 points. Leave out the rare cases of too fast and too slow cars. If you are looking at a platoon, you feel vehicles are going in the form of a queue, you look for the speed of the first cars in the queue. And heavy vehicles are to be avoided. So you need to keep these points in your mind. And I will add another point for your segments. Okay, I told you, you have a like 500-meter segment at least, right? So take the part of the 500-meter which is away from the intersection as much as possible. So if you are doing it before the intersection, you go back as possible. If you are going after the intersection, go as forward as possible. Okay, so that will solve the platoon problem as well. You don't have to look at the platoon because in the platoon you have 10 cars, but I will only take the observation for the first car. So that will create a problem for me. I'm losing the other cars. So if I just go forward a little bit, I can take the observation for all the cars. Okay, so go to the extent of your distance, which is as far away from the intersection as possible. Okay, so the platoon effect will be cancelled out. Okay, anybody has any questions? Okay, I see 13 people and I have 13 students. I'm assuming everybody is present. So no need to take the attendance. So if there are no questions, I'll see you next time, inshallah. Be safe. May Allah be with you. Masalam.